A metal sphere of radius r is charged to a potential V. Find the electrostatic energy stored in the electric field within a concentric sphere of radius 2r so that the electrostatic field energy stored outside the sphere of radius 2r equals that stored within it. So there is one sphere of radius r and it is charged with potential V. Then charge on it will be Cv, but we know that capacitance of spherical conductor is given by 4 pi epsilon naught r. So charge Q will be equal to 4 pi epsilon naught r. Now we consider another concentric sphere of radius 2r, and since charge contained in this sphere is also same, so let's find out the capacitance of bigger sphere, that is suppose C1. So it will be 4 pi epsilon naught times 2r. Now we will find out the energy stored in it. So energy stored, suppose it is U1. So it will be equal to charge contained in it squared divided by its capacitance. So charge contained in it will be this much. So it will become 4 pi epsilon naught RV square divided by C1, that is 4 pi epsilon naught times 2R. 16 pi square epsilon naught square R square V square divided by, this will also become 16 pi epsilon naught R. So we will get pi epsilon naught R times V square. So this is energy stored in the capacitor of radius 2r, sorry, in the sphere of radius 2r. Now let's consider second portion. This is the first portion. So keeping this charge stored in mind, charge stored energy stored in the sphere, we will proceed. So let's step part B. Now, for that purpose, we consider energy density. UE is given by 1 by 2 epsilon naught T square. And we know that its charge Q is contained here, and we want to find out electric field at distance R. So it is given by E equal to Q upon 4 pi epsilon naught R square. So we can write here UE equal to 1 by 2 epsilon naught times Q square divided by 4 pi epsilon naught R square whole square. So this will become 4 over 16 over 32. This will become Q square upon 32 pi square times epsilon naught R power 4. Now we consider a sphere. This is sphere of radius R, and this is sphere of radius 2r. Now we consider a thinner layer of thickness dr here, and we try to find out its volume. So here situation is capital R is less than a small r is less than 2r. So this also we are considering here. So now this goes R and their thickness dr. Let's find its volume. So volume, suppose it is d. So it will be area 4 pi r square times thickness dr. Energy stored in this. Energy stored in the volume equal to energy density times volume. So energy density, we have found this Q square divided by 32 pi square epsilon naught r power 4 into dV is this 4 pi r square dr. So this will become this energy stored. Suppose this is due here with a capital D. So it will become Q square upon 8 pi epsilon naught times r power minus 2 dr. Now our purpose is to find energy stored outside the sphere of radius 2r. So we can integrate it from 2r to infinity. So energy stored, suppose this is UE dash total. That will be integration of this. So integration Q square upon 8 pi epsilon naught r power minus 2 dr within limits 2r to infinity. So if we integrate it, we will get Q square upon 4 pi epsilon naught, sorry, 8 pi epsilon naught times r power minus 1 upon minus 1 limits 2r to infinity. Integration a to b fx dx gives fx limits a to b, or if we take minus side outside, so this will become fx, the limit will be b to b. So here, minus sign we want to remove. So we can write it as q square upon 8 pi epsilon naught, and this is just 1 upon r, and limits infinity to 2r. We simplify it, it becomes q square upon 8 pi epsilon naught, 1 upon 2r minus 1 upon infinity. And we know that 1 upon infinity is 0. So what do we get? We get UE dash equal to q square divided by 16 pi epsilon naught r. And we know that charge contained in a sphere of radius 2r is 4 pi epsilon naught times rb. We have already derived this. So we put this value here with 16 pi square epsilon naught square r square v square divided by 16 pi epsilon naught r. So this will become pi epsilon naught r times. And if you look back, you will see that energy stored inside the sphere of 2r, we got the same value. So we have proved the result. Now, let's consider next question. A large conducting plane has surface charge density 1 into 10 power minus 4 kilometer square. Find the electrostatic energy stored in a cubical volume of the edge 1 cm in front of the plane. So we know that electric field due to large conducting plane or non-conducting plate is given by E equal to sigma upon epsilon, and energy density UE is given by 1 by 2 epsilon naught E square, that is 1 by 2 epsilon naught E is the sigma square divided by epsilon naught square. Now, this is energy per unit volume. We consider this Q, whose volume will be, we will be 1 into 10 to the power minus 4 Q of centimeter in centimeter. Sorry. in a 1 cm is the side of the fluid. So it will be, the volume will be 1 cm multiplied by 1 cm multiplied by 1 cm, which is 10 power minus 6 meter cube. Now, energy stored capital UE will be UE times volume. So UE equal to 1 by 2 epsilon naught sigma square divided by epsilon naught square, 1 epsilon will come here, times the volume is 10 power minus 6. Now, so we put the values. So 1 by 2 sigma. Sigma is given as 1 into the power minus 4. So 1.0 into 10 to the power minus 4 square into 10 to the power minus 6 divided by 8.85 into 10 to the power minus 12. Now let's simplify it. So it becomes energy stored UE equal to 1 by 2 into this will become 10 power minus 8 and this is minus 6 and from denominator plus 12 divided by 2 into 8.85. So in numerator it will become 10 to the power, this is minus 14 plus 2. So minus 2 divided by 8.2 into 8.85. Now we simplify it. So we can write it 56, sorry, it will become 100 into 10 to the power minus 4. Then this will become 2 into 8.85. Here power will be so that we can easily divide. So 100 divided by this, this will become 8.85 into 2. That is 0, 7, 17. So 100 divided by 17.7 into 10 to the power minus 4. If we divide it, we will get 5.6 into 10 to the power minus 4 joule. So, which is our answer. Thank you for watching.